Yes, now in the previous lecture, we have calculated adjoint of matrix A. This was A and this was adjoint A. Now we are using A and its adjoint, and we will try to prove one theorem which will be useful in calculating inverse of a matrix. So before doing inverse of a matrix, one theorem we should know, and that theorem will create a question here, or just create a formula by which you can calculate the inverse of a matrix. So what I'm doing here, this is A and this is adjoint A. First, I do one thing, A into adjoint of A I calculate. You know how to calculate the multiplication of the two. 1, 1, 1, 2, 1, minus 3, minus 1, 2 and 3. It will multiply with the adjoint of it. This will be 9, minus 1, minus 4, minus 3, 4 and 5, 5, minus 3 and minus 1. Now when you will multiply these two, what will come, just check here. First, the product when you calculate, it will be P11, P12, P13, P21, P22, P23, P31, P32 and P33. This is the product matrix we have. Now what this product matrix comes, just check. First we go for A into adjoint of A. First product is P11, means first row, first column. So what it will come, 9 minus 3 plus 5. Okay. Then we go for P12, first row, second column. What it will be, minus 1. Then plus 4, minus 3. Then first row, third column. What it will come, minus 4, plus 5, minus 1. Okay. Then P21, second row, first column, it will be 18, then minus 3, and then minus 15. Then second row, second column, it will be minus 2, then plus 4, and then plus of 9. Then second row, third column, what it will come, minus 8, 2, 3 I am calculating, so second row, third column, so it will be minus 8, plus 5, plus 3. Then we go for P31, so third and first, what it will come, minus 9, minus 6, plus of 15. Then third row, second column, what it will be, 1, plus 8, minus 9. Then last will be what? It will be minus 4, plus 4 now, then plus of 10, then minus of 3. Now when you solve it, just check what the result you get here. 9 plus 5, 14, minus 3, it's 11. Is it 0? Yes. Is it 0? Yes. It will be 0. 13 minus 2, it's 11, then 0, then 0, then 0, and then it will be 11. Okay. And you can take 11 out from it, because I told you any scalar, if multiply with the matrix, it will multiply with each and every element. And same way, if you take common, it will be taken from all. All will give 11 common here, because the 0 can give anything common. So 11 and then 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. And now what is this 11? We should know that also. To get this, now I calculate what is determinant of A. This is A with you, and you know how to calculate determinant A. I told earlier, determinant A, when you calculate, this element is 1 into, this will be 3. I told you this method. I'll just revise it. Minus 1 power, because 1 element is here. Minus 1 power 2, 1. And then the determinant 1 minus 3, 2, 3. Then comes out to be this element. Minus 1 power 3, element is 1. Then leave this and this. Left is 2 minus 3 minus 1 and 3. And then the last is 1 power. Sorry, first minus 1 power. How much it is? 1, 3. So it will be 4. Element is 1 only. And then determinant. What it will be? 2, 1 minus 1 and 2. Now when you solve it, it will come 3 plus 6. Then it is minus here, that it will be 6 minus of 3. And then plus 4 plus 1. So when you solve it, it will be 9 minus 3 plus 5. Is it 11? Is it your 11? So what you will get in this case, this is coming equal to determinant A, and this will be I3. So one theorem now we got. What that theorem says? Theorem says that if you multiply A with adjoint of A, we get determinant A into In. The reverse also you can verify adjoint A into A. If you do, then also you will get this. That you can try yourself. So A into adjoint A is determinant A into In is adjoint A into A. This will be a number. This will be a matrix, identity matrix of same order, whatever the order of A. I taken the 3 by 3 matrix, so I got a identity for 3 by 3. So we will say A into adjoint A is determinant A into In is adjoint into A. This will be the theorem we should remember now. This is very important theorem. And this theorem will create your inverse. If you remember, I told you additive inverse in the beginning. I told you A plus minus A will give identity null. This was for addition. And one more property, A plus null matrix is A. So I told this was identity and this was inverse. Addition, for addition it was. At the same time we have done in multiplication, I told you A into I is coming as A. Then I told I is identity for multiplication. For multiplication. But we have not done inverse that time. I have not done any number, or I have not done the inverse condition. That means now what if you want to get the inverse, A into multiply with some matrix, I should get identity or it is A. What the matrix comes here, that I get the identity, then whatever this result will come. Just like A plus some matrix give identity. Same way A multiply with some matrix give an identity. This time identity is for multiplication. This was the identity for addition. So what matrix should multiply here that I get the identity? And that result I can get from here. What this says, just check here. I told you determinant A is nothing but a number. So if it is a number, I just divide all by determinant of A. So I write down A into adjoint of A by determinant A. This is coming identity and this is coming adjoint A by determinant A into A. Now is this form as this same? Just check here, A into some matrix. This is a matrix. This is a matrix because the cofactor matrix transpose divide by some number. Scalar, if you divide, that will divide with each and every element. So this will be another matrix. Then this is matrix multiply with A giving identity. Then this number or this matrix which you have will be called as inverse for multiplication. So whenever you want the inverse of a matrix, square matrix, every time I told you square matrix we should check. So whenever inverse for multiplication we want, inverse will be given by, so this inverse we denoted by A inverse. Here also I write down A inverse. Why will write A inverse? This is because you have done in numbers A, and this is 1 by A, cancel out, it will give 1. But it is, you can't write A inverse means 1 by A. No, this is wrong. You can't write this. This is wrong. Inverse means what this time? Adjoint A by determinant A. So A into adjoint A by determinant A is In, is adjoint A by determinant A is A. Then this will be called as A inverse. So one thing is clear now, whenever we want the inverse of a matrix, which is a square matrix, we should go for adjoint of A. I told you how to calculate that. Determinant by. So A inverse is nothing but adjoint A by determinant A. Adjoint A will be nothing but a cofactor matrix transpose, and that will be divided by a number. What that number will be? Determinant of A. So this theorem you should remember. Then you should remember the formula for calculating inverse of a square matrix. Thank you. So we should complete this portion now. Inverse one, that will be in RD. We will be having this exercise. Few questions better you calculate. It is exercise number 7. Exercise number 7 you start doing, in which they will be just saying you find out inverse. Properties and everything we'll do later, but first you should know how to calculate inverse, how to calculate the adjoint. These are the things you should make clear. Just do the questions, then things will be okay. Practice maximum questions, find out cofactors, matrix, adjoint matrix, then find out what is inverse. Do these questions 2 by 2 also, 3 by 3 also, you will get your answer. And if you're not getting answer, please send me on the WhatsApp, right? Your problem, I'll solve it. And I want that everyone should see this. Please do it at home. Then it will be better. You will prepare one chapter which will be of 12 marks. Clear. Thank you.